Okay, so today is lesson 5.7, and we're going to factor trinomials in the form x squared plus bx plus c. So notice that there is no coefficient out in front of our x squared term. So that's going to make it a little bit easier. We're also going to talk about the difference of two squares. That's what the dots stands for. And then we're going to talk about perfect squares. Something like this, okay? Or this, okay? So before we get into that, I just want you to think about what you know about factors and multiplying. So I'm thinking of two numbers that I can multiply together to equal 6 that add up to 5. Well, let's just list all the factors of 6 really fast. Let's see, 6 is the same thing as 1 times 6, 2 times 3. Okay, so if I took 1 multiplied by 6 and I added 1 and 6, 1 times 6 is 6, but 1 plus 6 is 7. So that is not going to work. But if I think about 2 and 3, let's see, 2 times 3 is 6, and 2 plus 3 is 5. So what are the two numbers or the two factors that I'm thinking of? I'm thinking of the number 2 and the number 3. All right, so next one, I'm looking for two numbers that multiply to 20 but add up to a negative 9. Let's see. Well, let's see, that's 10 times 2. 10 times 2 is 20, but they don't add up to a negative 9. And if I made both of those negative, negative 10 times negative 2 is a positive 20, but when I add those together, I get a negative 12. So let's try 4 and 5. 4 times 5 is 20, but they add up to a positive 9. However, if I make both of those negative, negative 4 times negative 5 is still positive 20, and it adds up to negative 9. So the two factors that I'm looking for are negative 4 and negative 5. So we're going to continue this process, and I want you to think about what two numbers are you able to multiply together to get a negative 6 and add up to a negative 1. So negative 6, and it adds up to a negative 1. So let's see. Negative 6, well, that's the same thing as positive 6 times negative 1, or negative 6 times negative 1. Times positive 1. Let's see, those don't add up to a negative 1. What about negative 2 and positive 3? If I multiply those together, that gives me a negative 6, but that adds up to a positive 1. So that means it's got to be negative 3 times positive 2. Negative 3 times positive 2 is negative 6. And when I add those together, I get negative 1. So my factors are negative 3 and 2. All right, so I want you to pause the video, and I want you to think about two numbers that you can multiply to get a negative 12. And when you add them up, you get a 4. I also want you to think about two numbers that you multiply together to get negative 49. And when you add them, you get 0. So go ahead and pause the video now. And then after you pause and you get those, I want you to come back and check and see how you did. Okay, so hopefully you figured out what two numbers you could multiply together to get negative 6 and add up to be 4. That is 6 and negative 2. And then the two numbers that you can multiply together to get a negative 49 add up to 0. That's negative 7 and positive 7. So we're factoring trinomials in this form. And just like I said, notice that there is no coefficient on my x squared. That means that the coefficient is 1, right? We just don't write that number 1. So you're going to continue to think about what two numbers can you multiply together to add up to something that also multiply together to get a number, but also add up to something. Well, the first thing I want you to think about is, how do you make x squared? Well, x squared is the same thing as x times x. So that's why you place the x in the first position of each parenthesis. Because remember, like yesterday, we want to end up with a binomial times another binomial. That's what we're going to end up with, right? We're going to take one binomial term and multiply it by another binomial term. So the idea is that for the numbers that go here, you're going to play that game like you did above. What two numbers multiply to this that add up to this? And that is what's going to go in those second positions for your parentheses. And then remember, like we did yesterday, you can always check by foiling. Okay, it's a good method to check by foiling. So we're just going to jump right in there. So I want you to think about, what two numbers can you multiply together to get 12? So on the time side, we need it to multiply together to be a 12. But when I add them, I want it to be a -7. So let's see, what two numbers can I multiply together to get a positive 12, but when I add them together, I get a -7? Well, I think that those two numbers are -3 and -4. -3 times -4 gives me a positive 12, and -3 plus -4 gives me a -7, right? So I'm going to take x minus 3 as my first binomial times x minus 4 as my second binomial. So this is the factored form of this, meaning these are the factors. That's what we're doing. We're factoring it, right? So these are the factors of this trinomial. Now let's suppose that you want to check it. Let's do a check really fast. Let's check this and make sure that this idea works. So I'm going to FOIL x times x. Well, that's x squared. X times -4. Well, that's -4x. -3 times x. Well, that's -3x. And -3 times -4. Well, that's positive 12. And notice that -4 and -3 become -7x, which is exactly what I had in my first term. So again, I want you to know that this is the factor. These are the answers. This is the factored example. Like these are the factors of x squared minus 7x plus 12. So you really want to write your answers as a product of two binomials. So let's do it again. What two numbers can I multiply together to equal 15? And when I add them, I get a -8. Let's see. Well, what about a -5 and a -3? Let's check. So a minus 5, because I know that a times a is going to give me my a squared, times the quantity a minus 3. So again, these are the factors of the trinomial a squared minus 8a plus 15. So again, what two numbers can we multiply together to get to equal 7? And we add them together to equal a positive 8. Well, 7 is prime, so its only factors are the number 1 and itself. 7 times 1 is 7. 7 plus 1 is 8. So those are my two terms. Remember that x squared is only made by taking x times x. So those are the first terms in each parenthesis. And then you use your factors, plus 7 plus 1. Okay? All right. Let's look at example 4. So this one is a little tricky, just because the last term has a variable on it as well. It has an a squared. So let's talk about, first of all, how do we get a b squared? Well, we get a b squared by taking b times b. How do we get an a squared? Well, we get an a squared by taking an a times an a. So the only thing that we need to do is use our times plus chart, right? To figure out what two numbers multiply together to equal 24 and add together to equal 10. Well, I think that that's 6 times 4 is 24, and 6 plus 4 is 10. So b plus 6a times the quantity b plus 4a. Now I'm going to check this by factoring, but I just want you to know that this is the factored form of the trinomial b squared plus 10ab plus 24a squared. But let's go ahead and factor this. Let's see, or FOIL this, sorry. B times b is b squared. B times 4a is a positive 4ab. 6a times b is a positive 6ab. And 6a times 4a is a positive 24a squared. So b squared and 24a squared, that's what I was looking for. And 4ab plus 6ab, well, these two terms combine to make the 10ab. So we did it properly. All right, so we're going to continue doing this. So what two numbers can I multiply together to equal negative 14? And when I add them, I get a negative 5. Let's see. Well, that looks like negative 7 times positive 2. That equals negative 14, and negative 7 plus 2 gives me my negative 5. So V minus 7, because it's a negative 7, times the quantity V plus 2. What two numbers can I multiply together to get a negative 56? But when I add them, I get a negative, that says negative P, but remember there's a 1 in front of there. So a negative 1. I'm going to wait for a minute, let you think about it. Hopefully you can come up with the two numbers that multiply together to equal 56 and just make one of them negative. I would say that the most challenging thing when it comes to factoring is that many of you don't know your math facts. You don't know 3 times 7, 9 times 2, 9 times 7, things like that, and you struggle with it. So I need a negative 1. I know that 56 is the same thing as 8 times 7. When I add them together, I want a negative 1. So I need 8 to be negative. Negative 8 times 7 gives me negative 56. Negative 8 plus 7 gives me my negative 1. So my factors are P minus 8, because the 8 is negative, times the quantity P plus 7. All right, let's look at example P. I don't even know what number we're on. I think this is example 7. So let's see. P squared. I know that that's P for each term, P times P, right? Let's see, what two numbers can I multiply together to get a negative 63? And when I add them, I get a positive 2. Well, let's see. 63 is the same thing as 9 times 7. So positive 9 times a negative 7 gives me my negative 63, and positive 9 plus negative 7 gives me my positive 2. So since the 7 is the negative term, I write it as P minus 7. All right, let's do it again. What two numbers can I multiply together to get negative 10? And when I add them together, I get positive 2. So let's see, 10 is made by taking 10 times 1, or negative 10 times positive 1, or vice versa, but those are none of them going to add up to 2. And I also can do 5 times 2. Now, if I make one of these negative, 5 times negative 2, that gives me a positive 3. If I make it a negative 5 times a positive 2, that gives me a negative 3. There are no factors that I can multiply together to get a negative 10 that when I add them, I get a positive 2. So this is already in the simplest form. You cannot factor this with integers. It is factorable, but it's only factorable with decimals. It's not factorable with integers. We're not ready to learn that yet, okay? What about this one? Well, this looks like a dots. Difference means a subtraction problem of two squares, x squared and 64. X squared is made by taking x times x, and 64 is made by taking 8 times 8. So these are perfect squares, right? So the difference of two squares, well, remember that that means that these, when you have two terms, you had conjugates. Remember we talked about that conjugate, that middle term canceling out. So x squared plus or minus 64 is factored with x plus 8 times x minus 8. This is the factored form. Okay, what about the dimensions of a parallelogram whose area is x squared plus 5x minus 84? So that means that I'm looking for two numbers that multiply together to give me a negative 84, but when I add them, I get 5. Let's see, well, 84 is the same thing as 7 times 12. If I make the 7 negative, negative 7 plus 12 gives me the positive 5 that I'm looking for, and negative 7 times 12 gives me the negative 84. So again, I have x minus 7 times the quantity x plus 12. Now, what if you had found your factors and you wrote it as 12 times negative 7? Is x plus 12 times the quantity x minus 7, are these the same thing? Yes, they are. Because remember, with multiplication, you can change the order. 2 times 8 is the same thing as 8 times 2. Okay, so now we're going to talk about special problems called the difference of two squares. We actually just did a sample problem like that. So the acronym is DOTS, difference of two squares. So you recognize these because they only have two terms, like x squared and 36. Both of these terms are perfect squares, and they're joined by a minus sign. So remember that these factor using their conjugates, right? We factor these using the conjugates. So the square root of x squared, or what two numbers do you multiply together to get x squared? Well, that's x times x. What two numbers do you multiply together to get 36? Well, that's 6 times 6. And one is joined with a minus sign and one is joined with the plus sign. Again, it doesn't matter if I write it as x minus 6, the quantity x minus 6 times the quantity x plus 6, or the quantity x plus 6 times the quantity x minus 6. Again, the order does not matter because it's multiplication. These are interchangeable, okay? So m squared is a perfect square, 49 is a perfect square. I'm going to make a list of perfect squares up here. So m plus 7, m minus 7. But I'm going to go right up here and maybe I'm going to erase this example and just list out some perfect squares. So let's see. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 squared, 36, 7 squared is 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, 11 squared, 121, 12 squared, 144, 13 squared, 169, 14 squared, 196, 15 squared, 225, 16 squared, 256. So those are the perfect squares up through 16. So it's beneficial for you to know those. Really, you should have up through 25. 25 squared is 625. Okay. You should have up through 25 times 25 memorized. It's just going to help you. So let's see. P squared comes from P times P, right? 144, that's the perfect square, right? It's positive 12 and negative 12. 12 times 12 is 144. So minus 12. Let's see. 4 is a perfect square, and so is t squared. So that's made by taking 2t times 2t. 25 comes from 5 and 5. Join one with a plus, one with a minus. Let's see. 9t squared. Well, that's made by taking 3t times 3t, but this is not joined by a minus sign. This is not the difference of, this is not the difference of two squares. This is the sum of two squares. And those don't factor with integers. So this is already in this is factored as much as it can possibly be with integers. Okay. But this example does have the difference of two squares. 64 is made by taking 8 times 8. M to the fourth is made by taking m squared times m squared. Okay. 9 is made by 3 times 3. And p to the 6, well, that's from p cubed times p cubed. Join one with a plus, one with a minus. Okay. Let's see, 169, well, that's 13. R squared is R, so I have 13R times 13R. 256, well, that's 16 plus 16 minus 16. Okay, so that's what the difference of squares look like. If I have a rectangle whose area is 4x squared minus 49, notice that those are the difference of squares. Ding, ding, dong it. I hate it when I do that. Those are the difference of squares. So the square root of 4 is 2, so that's made by 2 times 2. The square root of x is, or sorry, of x squared is x. 49 is made with a 7 times a 7. Join one with a plus and one with a minus. So find the sides of the rectangle. Well, the first one is going to be 2x minus 7, and the other side is 2x plus 7. Okay. All right. So the last one is factoring perfect squares. So I said to you yesterday, remember we learned about special cases. And this means we take the first term and we square it. And then we take the product of the two terms and we multiply it by 2. And then we take the last term and we square that. And it works the same way when it's joined by, when it's a difference, right? A difference. So if I square a difference, I still am going to take the first term and square it, but now I'm going to subtract the product of the two terms multiplied by 2, and then I'm going to square the last term. And a negative squared gives me a positive. That's why it's plus. So it's helpful, and I told you yesterday, remember, this is helpful because it helps you recognize trinomials that are made from perfect squares. So the way that you want to look at it is the middle term is twice the square of the last term, provided that this coefficient is 1. So let's think about what I just said. So when a trinomial factors into a perfect square, it means that it's made from the square root of this number. Well, that's 3. And this is twice that, times 2, which is 6. So this actually started as x plus 3, the quantity squared. So again, we're going to check this with a FOIL just to make sure you understand what's going on. So if I FOIL this, well, remember this is x plus 3, the quantity squared is really x plus 3 times x plus 3. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So that becomes x squared plus 6x plus 9, which is what you started with. So the factored form is x plus 3, the quantity squared. So let's see. These are joined by two addition signs. So that means I'm going to take sum. It's going to be a sum. Well, what is the square root of 100? It's 10. Is 10 times 2 20? Yes, it is. This next example has a subtraction sign in it. So that means that we're going to do the difference. We're going to square a difference. So x squared, the square root of that is x. 25, the square root of 25 is 5. Is 5 times 2 10? Yes, it is. So this is made from x minus 5, the quantity squared. Let's see. Let's look at the square root of 81. The square root of 81 is 9. 9 times 2 is 18. And that's not true of this one. So this one is not factorable with integers. Remember, integers are positive and negative whole numbers. It is factorable. It's factorable, but not with integers. You'd have to use the quadratic formula for that. The last one says find the side of a square. So remember, what do you know about squares? Their sides are the same. So this is going to be some measurement squared. Well, let's see. What is the square root of 16? That is 4. The square root of x is x. And because this is a positive number, I know it's going to be joined by a plus, and 4 times 2 is in fact 8. So this would work out. It's this dimension of my square, the side measurement of my square is x plus 4 because it's factored as x plus 4, the quantity squared. We just wanted to know the measure of one side, right? Okay, so your homework is page 7 and page 8. Page 7 and page 8. So I know that there are 42 problems. I will go through and eliminate maybe 5, probably not much more than that. So just, I need to look through and see which ones I want to eliminate. So make sure you check Canvas to see what problems you can skip or omit from your assignment. And that's it. Thanks.